Good day, everyone. Our report is all about foundation in business intelligence, databases, and information management. The reporters are Maria Catherine Pila and Diana S. The database approach to data management. Database is a collection of related files containing records on people, places, or things. Prior to digital databases, business used file cabinets with paper files. So, a database is a structured collection of data that is organized in a way that facilitates efficient storage, retrieval, and manipulation of information. It serves as a central repository for storing and managing data related to various aspects of an organization or domain. There are components of database, files and records. In a database, data is organized into files, which are collection of related records. Each records represent a single instance or entry of data. For example, in a customer database for a retail business, each record may represent a unique customer and contain information such as name, address, phone number, and purchase history. Entities. An entity is a generalized category or object about which data is stored in a database. Entities can represent various real-world concepts such as people, places, things, or abstract concepts like orders, transactions, and etc. For instance, in a manufacturing database, entities could include suppliers, parts, employees, customer, and etc. Attributes. Attributes are specific characteristics or properties of each entity that describe the entity features or qualities. They define the type of information that can be stored about an entity. For example, for a supplier entity, attributes could include name, address, contact person, phone number, and etc. While for a part entity, attributes could include description, unit price, supplier ID, quantity in stock, and etc. Relational databases organize data into two-dimensional tables or relations with columns and rows. Each table represents a specific entity or concept within the database. For example, in a company database, you might have tables for customers, suppliers, parts, and sales. Rows or columns store data representing an attribute or properties of the entity being represented. Rows store data for separate records or tuples, where each row contains data corresponding to one instance or record of the entity. Field uniquely identifies each record. The primary key is a special key field designated in each table that serves as a unique identifier for all the information in any given row. Characteristics of a primary key. First is one field in each table or single field. There can be only one primary key field defined for each table. Second is cannot be duplicated or non-duplicability. The primary key value cannot be duplicated or repeated across different records in the table. Third is provides unique identifier for all information in any row. Or uniqueness. A primary key must ensure uniqueness within its respective table. No two rows in the table can have the same value in the primary key fields. A relational database organizes data in the form of two-dimensional tables. Illustrated here is a table for the entity supplier showing how it represents the entity and its attributes. The table is named supplier, indicating that it stores information related to suppliers. Columns or fields. Supplier number. This is the key field or primary key of the table. It uniquely identifies each supplier record in the table. Supplier name represents the name of the supplier company. Supplier state contains the street of the primary street of person for the supplier. Supplier city stores the supplier city. Supplier state contains the state of the supplier. Supplier zip contains the zip code of the supplier. Rows or records. Each rows in the table represent a separate supplier record. For example, the first row represents a supplier with supplier number and etc. Key field or supplier number. The supplier number column serves as the key field or primary key for this table. It ensures that each supplier record has a unique identifier within the table. No two suppliers can have the same supplier number. Data for the entity part have their own separate table. Part number is the primary key and supplier number is the foreign key. Enable users to find related information from the supplier table about the supplier for each part. The table is named part, indicating that it stores information related to different parts or product. Columns are fields. Part number is a primary key. This column serves as the primary key for the part table. It uniquely identifies each part record within the table. Part name describes the part or product in detail. Unit price represents the price of a single unit of the part. Supplier number or foreign key. This column is a foreign key that establishes a relationship between the part table and the supplier table. It links each part to its respective supplier based on the supplier unique supplier number. Establishing relationships. Entity relationship diagram used to clarify table relationships in a relational database. Entity relationship diagram or ERD. An entity relationship diagram is a visual representation that illustrates the entities or tables, attributes or columns, and relationships between entities in a relational database. ERD or entity relationship diagram help database designers and developers understand the database structure, identify key entities and their attributes, and define the relationships between entities. Relational database tables may have one-to-one relationship, one-to-many relationship, and many-to-many relationship. In a one-to-one relationship, each record in Table A is associated with exactly one record in Table B, and vice versa. This type of relationship is less common but may be used when two entities have a unique and direct correspondence. For example, a person table might have a one-to-one relationship with a driver license table, where each person has only one driver's license. In a one-to-many relationship, each record in Table A can be associated with multiple records in Table B, but each record in Table B is associated with only one record in Table A. For example, a department table may have a one-to-many relationship with an employee table, where each department can have multiple employees, but each employee belongs to only one department. In a many-to-many relationship, each record in Table A can be associated with multiple records in Table B, and vice versa. This type of relationship requires a joint table, or also known as an intersection tables, to link the two tables together. The joint table contains foreign keys from both tables, creating a bridge between them. For example, a student table may have a many-to-many relationship with a course table, where each student can enroll in multiple courses and each course can have multiple students. A simple entity relationship diagram. This diagram shows the relationship between the entities supplier and part. The supplier entities. This entity represents the supplier or vendors who provide parts or products. Part entities. This entity represents the individual parts or products that suppliers supply. The diagram shows the type of relationship that exists between supplier and part. In database design, common relationship types include one-to-one, one-to-many, and many-to-many. For example, a one-to-many relationship could mean that one supplier can supply many different parts, but each part is supplied by only one supplier. Normalization is a crucial process in database design aimed at streamlining complex groups of data to improve data integrity, reduce redundancy, and enhance overall database efficiency. It involves organizing data into multiple related tables while adhering to specific rules and principles. First is minimize redundant data elements. Redundant data refers to data that is unnecessarily repeated across multiple records or tables in database. This helps in conserving storage space, reducing data update anomalies such as inconsistencies due to redundant data, and ensuring data consistency. Second is minimize awkward many-to-many relationship. Many-to-many relationship between entities can lead to complexities in data management and querying. By normalizing data, awkward many-to-many relationships are transformed into one-to-many or many-to-one relationship using intermediary table, also known as junction or associative tables. This simplifies data relationships and improves the overall structure of the database. Third is increase stability and flexibility. Normalization increases the stability and flexibility of a database schema by reducing dependencies and improving data or organization. It allows for easier modification, updates, and function of the database without causing cascading changes across the entire system. Changes in one part of the database schema do not necessarily impact or other parts, leading to a more but an adaptable database design. Referential integrity rules used by relational database to ensure that the relationships between coupled tables remain consistent. Example: when one table has a foreign key that points to another table, you may not add a record to the table with foreign key unless there is a corresponding record in the linked table. Order report is a document or representation that provides detailed information about order placed within a system or database. The report typically includes data related to supplier, line items, or individual items ordered, and overall order information. The shaded areas on the report indicate which data is sourced from specific tables in the database, such as supplier, line item, and order tables. The database does not maintain data on extended price or order total because they can be derived from the other data in the tables. Supplier data. The shaded areas representing data from the supplier table would include information about the supplier involved in the orders. This data may include supplier ID, supplier name, address, and any other relevant details specific to supplier. Line item data. The shaded areas representing data from the line item table would include details about individual line items within each order. Line item data typically includes items ID, description, quantity ordered, unit price, and possibly other attributes related to the specific items being ordered. Order data. The shaded areas representing data from the order table would include overarching information about each order. This could include order ID, order date, customer ID, or if applicable, shipping information, and any other metadata associated with the entire order transaction. Final database design with sample records. The final design of the database for suppliers, parts, and orders has four tables. The line item table is a joint table that eliminates the many-to-many relationship between order and part. This design helps organize and streamline data management within the database. Additionally, including sample records can further illustrate how data is structured and how the relationships between entities are managed. The supplier. This table stores information about supplier such as supplier number, supplier name, supplier street, supplier city, supplier state, and supplier zip. Part. This table contains data related to parts or product including part number, part name, unit price, supplier number. Order. This table manages information about order placed, including order number and order date. Line item. This join table connects order with parts, eliminating the many-to-many relationship between orders and parts. It typically includes column like order number, part quantity, and possibly other attributes relevant to line items in an order. Relationship diagram for a database with 4 tables. This diagram shows the relationship between the entities supplier, part, line item, and order. The supplier entity represents suppliers or vendors providing parts. It would have attributes like supplier ID, name, address, and etc. And the part entity represents individual parts or products supplied by the supplier. Attributes could include part ID, name, description, quantity available, unit price, and etc. The order entity represents order placed by customers. Attributes might include order ID, order date, customer ID, shipping address, and etc. Line item entity serves as a join table to manage the many-to-many relationship between orders and part. It would include attributes like order ID, part ID, quantity ordered, and possibly other relevant details. Database management system. Specific type of software for creating, storing, organizing, and accessing data from a database separates the logical and physical views of the data. Logical view. This represents how end user perceive and interact with the data. It includes concepts such as tables, queries, view, and relationships that are meaningful to users. While the physical view this refers to how data is actually stored, structured, and organized within the storage media, for example, disk, memory. It includes data such as data storage formats, indexing methods, file organization, and access paths. Example of DBM is Microsoft Access, DB2 Oracle Database, Microsoft SQL Server, MySQL. Resources database with multiple views. A single human resources database provides many different views of data depending on the information requirements of the user. Illustrated here are two possible views, one of interest to a benefits specialist and one of interest to a member of the company's payroll department. Benefits specialist view. This view is designated to provide comprehensive information related to employee benefits, insurance, and related matters. While in the payroll department view, this view focuses on payroll-related data and financial aspects related to employee compensation and deductions. Operations of relational DBMS. Select. Creates a subset of all records meeting stated criteria. The select operation is used to retrieve a subset of records from a table that meets specific criteria or conditions. For example, consider a table of employees where you want to select only those employees who are managers. Join combines relational tables to present the server with more information than is available from individual tables. The join operation combines data from multiple relational tables based on a related column or key to provide a unified view of information that is not available from individual tables alone. For example, suppose you have two tables, employees and departments. You can perform a join to get information about employees along with their respective department names. Project creates a subset consisting of columns in a table. Permits user to create new tables containing only desired information. The project operation creates a subset of columns from a table, retaining only the specified columns while excluding others. For example, consider a table of customer data where you want to select only the customer ID and name columns. Abilities of database management system. First is data definition capabilities. Specify structure of content of database. DBMS allows users to define the structure of the database content using data definition statement. This involves creating tables, specifying columns or attributes, defining data types, setting constraints such as a primary key, foreign key, and unique constraints, and establishing relationships between tables such as one-to-one, one-to-many, or many-to-many relationships. Data dictionary, automated or manual file storing definitions of data elements under characteristics. A data dictionary is a component of DBMS that stores metadata or data about data elements under characteristics. It can be either automated or integrated within the DBMS or manual maintained separately. The data dictionary contains information such as data elements name, data types, lengths, default values, descriptions, and constraints. It serves as centralized reference for understanding the database structure and ensure consistency in data definition across the organization. Querying and reporting, data manipulation language, or DML. DBMS provides a data manipulation language that allows users to interact with the database to retrieve, insert, update, and delete data. Common DML commands include select for querying data, insert for adding new data, update for modifying existing data, and delete for removing data. Structured Query Language or SQL. SQL is a standard language used for interacting with our relational databases. It provides a powerful set of commands for querying and manipulating data. SQL statements can be used to retrieve specific data subsets, perform calculations, join tables, filter results, and more. Microsoft Access Query Building Tools. DBMS such as Microsoft Access provide user-friendly query building tools that allow users to visually design queries without needing to write complex SQL code. These tools often include graphical interfaces for selecting tables, defining criteria, and specifying output formats. Lastly is report generation, for example, Crystal reports. DBMS integrates with report generation tools like Crystal or Reports, which enable users to create formatted reports based on database queries. These tools offer a feature for designing reports layout, adding charts and graphs, applying filters, and scheduling automated report generation tasks. Reports generated using such tools provides insights into the data and support informed decision making within organizations. Access Data Dictionary features refers to the capabilities and functionalities within Microsoft Access that allow users to create and manage a data dictionary. Microsoft Access has a rudimentary data dictionary capability that displays information about the size, format, and other characteristics of each field in a database. Displayed here is the information maintained in the supplier table. The small k icon to the left of the supplier number indicates that it is a k field. Access Query. An access query is a powerful tool within Microsoft Access that allows users to retrieve, manipulate, analyze, and represent data stored in their databases. Illustrated here is how the query in Figure 5 to 10 would be constructed using Microsoft Access query building tools. It shows the tables, fields, and selection criteria used for that query. Object-oriented DBMS or OODBMS stores data and procedures that act on those data as objects to be retrieved and shared. Better suited for storing graphic objects, drawings, video, than DBMS designated for structuring data only. Used to manage multimedia components or Java applets in web application. Relatively slow compared to relational DBMS. Object relational DBMS provide capabilities of both types. Object-oriented database management system are a type of database management system that extends the capabilities of traditional relational databases by incorporating object-oriented concepts.
Using databases to improve businesses' performance and decision making. Databases provide information to help the company run the business more effectively and help managers and employees make better decisions. Tools for analyzing, accessing vast quantities of data. Number 1. Data warehousing. Number 2. Multidimensional data analysis. Number 3. Data mining. Number 4. Utilize web internal and databases. Data warehouse. Database that store current and historical data that may be interest to decision, consolidate and standardize data from many system operation or transactional databases. Data can be accessed but not altered. Data mart. Subset of data warehouses that is highly focused and isolated for specific population of users. The data warehouse extracts current and historical data from multiple operational systems inside the organization. This data combined with data from external sources and reorganized into the central database designed from the management, reporting, and analysis. The information directory provides user with information about the data available in the warehouse. Business intelligence, multidimensional data analysis, and data mining. Business intelligence tools for consolidating, analyzing, and provides access to large amount of data to provide decision making. Software for database reporting and querying. Tools for multi-dimensional data analysis or online analytic processing. Data mining. HANA's internal gathered and analysis customer data to create gambling profile and identify most profitable customers. Business intelligence, a series of analytic tools works with data stored in databases to find pattern and insight for helping managers and employees to make better decisions to improve organizational performance. Online analytical processing support multidimensional data analysis, enabling users to view the same data in different ways using multiple dimensions. Each aspect of information, product, pricing, cost, region, or time period represent a different dimension. Comparing sales as in June versus May and July. Enable users to obtain online answers to add the hook questions such as this fairly rapid amount of time. Multi-dimensional data model. The view that is showing is product versus region. If you rotate the cube 90 degrees, the face that will show is product versus actual and the projected sale. If you rotate cube 90 degrees again, you can see the region versus actual and the projected sales overview and or positive. Data mining. Find the hidden pattern and relationships in large databases and inference rules from them to predict future type of information obtainable from data mining, associations, occurrence linked to single event, sequences, event link over time, classifications, pattern describe a group of an item below, cluster, discovering a yet unclassified groupings, forecasting, uses series of value to forecast future values. One popular use of data mining, analyzing pattern in customer data from one-to-one marketing campaign or for identifying profitable customers. Predictive analysis uses data mining techniques, historical data, and assumption about future conditions to predict the outcomes of event, such as the probability of customer will respond to an offer or purchase the specific product. Data mining versus privacy concern. Used to create the detailed data image about each individual. Text mining, unstructured data, most likely text files, account for 80% of an organization useful information. Text mining allows businesses to extract key elements from discover patterning and summarize a large unstructured data sets. Web mining, discovery and analysis of useful pattern and information from the web. Content mining, structured mining, and usage mining. Databases and the web. Firms use the web to make information from their internal databases available to customers and partners. Middleware and other software make this possible. Number 1, web server. Number 2, application server or CGI. Number 3, database server. Web interfaces provide familiarity to use and savings over the designing and rebuilding legacy system. Linking internal databases to the web. Here's the picture. The client with the web browser, the internet and the web server, the application server and the database server. Tapos ang database. Users access organizations' internal database through the web using their desktop PCs and web browser software.
Thank you for listening.